Welcome back. In this lesson, we're going to look at the different types of maps. So a map is, remember, a model of something like the topography of the ground or the surface of the earth. And so a map is going to be distorted in a lot of ways. If you try to put a three-dimensional object like the globe, like the earth, which is a sphere, onto say a sheet of paper or a flat screen, you're going to have some distortions because it's very hard to get a three-dimensional object onto a map of a two-dimensional space. So we're going to look at the different types of maps based upon what you're using the map for. If you are using a map for one thing, as long as the distortion is not what you're looking at, that map could be very useful. And then you want to use the map that is less distorted for the part of the map that you're going to be looking at. So let's look, there's three. Okay, so in this section, we're going to be looking at the different types of maps. And there are many different types of maps depending on what you need them for. So just in this picture, you've got the first one, which is a spherical map. And we would call a spherical map a globe. And a globe is the most accurate in terms of not just the shapes of the countries, but also how much land that they occupy. Because essentially it's a little miniature representation of the earth with the countries where they belong on the ball. There are other reasons, though, to not have a globe. They're cumbersome. You can't put them in your pocket. You can't put them on in your iPhone. So it's a really hard way to have a map. So other maps are configured that are more useful, but by having them be easy to use, you're giving up accuracy. So let's look at the second one. The second one is a projection as though light were coming from the inside of the globe and shining on a screen that is a cylinder around the earth. So the whole idea would be the globe would be on the inside of the cylinder, and light would be shining out of the middle of the earth and projecting, if you want to think of it as a projection, onto the screen. Well, anything towards the middle is going to be more accurate than things on the outside. Okay, so you're giving up clarity on the poles if you have this kind of a map. If you have a different kind of a projector to where, let's say, a ball was sitting inside a cone, to where that the cone was touching the ball all the way around at a circle. So imagine like a snowman with a party hat on, okay, to where the head of the snowman was touching the inside of that hat somewhere. Anywhere along that line where the globe is touching that projector, that's going to be very accurate. Anything farther away from that line is going to be more iffy. Okay, so you're just giving up a clarity for convenience. And so you would use one map in one case, in another case, depending on what the pros and cons of that map would be. So let's look at what projections are. So you can't really have a spherical map convenient, so a paper map is the most convenient that you could have, and you've had paper maps since the end of the Middle Ages. And so imagine a projected light coming through all points on the sphere and projecting onto a sheet of paper that's wrapped around that globe. That's the idea of projection. Okay, so as it projects, you are going to have anything close to where the light's coming from be more accurate than farther away from where the light's coming from. So in this case, the equator would be very accurate. The North Pole and the South Pole would be very inaccurate. Okay, so the closer you are to where the light's coming would be more accurate, and farther away. Okay, so let's look at the different types of maps. The first one is what I would consider the map that I've always known, and that is the Mercator Map. These are named after people. And so Mercator is coming from a certain point on the inside of the globe. So imagine the inside point of the Earth with light coming out, and it's shining through the city, shining through that mountain, it's shining through that river or creek, and then projected onto the map. Okay, and so that is called Mercator. And Mercator is going to have the shapes of the land masses going to be rather accurate, but the masses are going to be a little distorted as it gets towards, say, Greenland or Antarctica, where it's farther away from the equator. The next type of map that you're going to see is called a conic or a conic projection. So imagine a cone is the screen, and the light is coming from the inside of the Earth and projected onto that screen. Well, anywhere that's close, say where it's touching, is going to be very accurate. That's going to be wherever the globe would touch that cone would be rather accurate. Anything farther away is going to be more distorted. You're going to get more of a distortion. So in the case of, say, North America, you could fit most of North America on that map. And so if you were doing traffic maps or road maps for truckers, you would use a conic projection, because over a small area, it's rather accurate. Now, you're not going to have a map that's going to have Nebraska and Argentina on the same map usually. For that reason, you would have small maps of just a local area, and that would normally be a conic map. The last kind of map is called a genomic map. Okay? And a genomic map is a screen that would be flat, touching one point. Okay, only one point. So imagine that you would have it touching the North Pole, like in this picture, it's touching the North Pole. Anything around the pole would be very, very accurate. Anything towards the outside is going to be more and more distorted. Okay, so a lot of times, if you are going to do, if you're going to have a sailing map where you want something to be from one point to another, then you would want a very accurate map at that point. So you would have a map, say at one point, with a genomic projection of that area, and then a separate map with a genomic region of that area. So let's say you're sailing, and we're sailing from Spain to Florida. You would have a map that was based upon the area you're sailing from, and then a different map towards the area that you're sailing to, and all of those features of the coastline would be very accurate because it's very close to wherever it was being touching, where the sphere was touching the screen in this case. So that's called gnomonic. A gnomonic, anything with a G in is going to be Greek. Gnomonic projection. Okay, it's a one-point projection where there's no distortion at that point, but further away from that point is going to be more distorted.